In this module, we'll link PKI to what really controls access, your identity systems. You'll see how certificates underpin strong user and device authentication, feed conditional access, and act as a first-class signal in your zero trust and IAM architecture. Traditional PKI often sat as an isolated security island, enforcing boundaries but not really understanding identity. In modern environments, certificates become a rich identity signal. They don't just encrypt, they prove exactly which user, device, or workload is involved in a way that's cryptographically undeniable. That lets PKI participate directly in zero trust. Access isn't granted because something is on the network, but because a trusted certificate asserts the right identity and purpose. To make that work, certificate lifecycles must track identity lifecycles so joiner, mover, and leaver events automatically drive issuance and revocation. Treat PKI integration as a maturity journey, not a single project. At the foundation, you align certificates with directory identities and stable naming. If that layer is weak, everything above it becomes fragile. Next, you introduce automation. Templates, group policy, and auto-enrollment so user and device certs appear and renew without tickets. Then you build the cloud bridge, integrating with ADFS and Azure AD so on-prem identities and certificates participate in federation. At the highest maturity, PKI directly feeds conditional access, Intune, and privileged access workstations as part of your zero trust gate. The core design decision in PKI, identity integration, is how you map certificates to accounts. Active Directory should be the authoritative source. Every identity in a certificate must be derivable from AD attributes, not invented in the PKI. Use stable identifiers, typically UPN for users and FQDN for devices. Avoid display names or email addresses that can change. Then bind purpose tightly using EKUs, smart card logon, client auth, or others as required. That combination of solid mapping and clear purpose makes certificate-based authentication predictable and auditable. Auto-enrollment really lives inside group policy. You design certificate templates, but GPO controls who actually gets them and when. You scope the policy to security groups or OUs, and the client processes it at logon, startup, or during a policy refresh. That evaluation triggers certificate requests and renewals. From the user's perspective, everything is silent. Keys are generated, certs are enrolled, and stores are updated with no prompts. Because it's policy-driven, you also gain lifecycle control. Predictable renewals, key archival, and cleanup, all enforced centrally. Choosing an authentication method is always a trade-off between security, usability, and operational overhead. Password-only authentication offers almost no phishing resistance and high user friction, yet still depends on directory infrastructure. Basic MFA with SMS or push improves security, but remains phishable and adds noticeable friction and mobile dependencies. Certificate-based authentication flips that balance. It's highly phishing resistant, usually low friction after enrollment, and naturally carries device context. The trade-off is heavier infrastructure and lifecycle management, which is exactly what a well-designed PKI and CLM stack is built to handle. When you integrate PKI with ADFS versus Azure AD, think in 3 dimensions. First, trust anchors. ADFS typically trusts your on-prem enterprise SKAs directly. Azure AD expects you to upload selected routes and intermediates to the cloud. That alone changes who can issue certificates that are usable. Second, claim extraction. ADFS gives you very granular, rejects, and OID-driven rules. Azure AD focuses more on claims-based mappings built into the identity provider. Third, capability focus. ADFS shines as an internal STS doing SAML and OIDC signing, while Azure AD enables direct cloud certificate-based authentication and Intune-backed device identity. Intune acts as the central MDM engine that operationalizes your PKI for devices. It pushes SCEP or PKCS certificate profiles to managed endpoints, phones, laptops, tablets, and even infrastructure interfaces. From the PKI perspective, this is your enrollment and renewal orchestration layer. You define which certificate template applies to which device group, and Intune handles distribution and key generation. Because it's platform agnostic, you get consistent policy across corporate and BYOD. Continuous monitoring then closes the loop by flagging failed enrollments and upcoming expirations before they turn into outages. Here's how PKI and Intune-backed device management combine into a powerful gatekeeper for cloud access. First, the device must satisfy Intune compliance. It's managed, domain-joined where required, and meets your security baseline. That's the policy check. Next comes the cryptographic check. The device presents a certificate that chains to your trusted CA, isn't expired, and hasn't been revoked. Dynamic revocation is crucial. The moment you revoke or wipe the device, that certificate fails validation, and access to cloud apps is instantly cut off without changing any app configuration. Just-in-time certificates are a powerful pattern for hardening privileged access. Instead of giving an admin a long-lived credential, you issue a short-lived certificate only for the approved session. When the window closes, the credential simply expires. This directly reduces credential theft risk. Even if an attacker captures the certificate or key, it's useless outside that tight time boundary. You can go further by binding the certificate to a hardened origin, such as a privileged access workstation, using strict EKUs and policy. Now the cert is both time-bound and device-bound, dramatically shrinking the usable attack surface. Think of PKI as continuously reacting to identity lifecycle events coming from HR and IAM. When someone joins, HR creates the identity, IAM provisions accounts, and PKI should automatically issue the appropriate user, device, and smart card certificates. As they move roles, IAM updates group memberships and access. PKI needs to re-evaluate templates, EKUs, and validity periods to match the new risk profile. When they leave, HR termination should trigger immediate revocation, key destruction where needed, and device certificate cleanup. Robust PKI design wires these joiner, mover, leaver triggers directly into your certificate workflows. Think of this ecosystem as 4 pillars forming a single system of record for identity and trust. Active Directory anchors user and device identities. Certificates from the enterprise keys extend that identity into ADFS, Azure AD, and Intune, so the same cryptographic credentials work on-prem and in the cloud. Intune and device policies continuously report health and compliance. Conditional access then evaluates identity, device posture, and certificate validity together before granting access. When PKI is designed this way, certificates become the common currency of trust. Lifecycle events mirror identity changes, and zero-trust decisions are enforced consistently everywhere.